Okay, here on these, we're going to use trigonometry to find the missing sides of these right triangles. Important disclaimer is make sure your calculator here, you hit mode and make sure it's on degree mode. So I'm going to switch that over. If you're on the Calculator X84 app, you can just do that. If you're on your own graphing calculator, you can do that as well. It's just the mode. Make sure it says degree. Make sure that's highlighted. If not, scroll down to it, hit enter, and then second mode gets you out of that screen on a TI-84 calculator. Okay, the thing I'm going to encourage my students to write at the top of their page here is an acronym to help you remember the trig functions. It's SOHCAHTOA, and what that stands for is the sine of an angle. I'll just call it sine of x, and then it equals the opposite over the hypotenuse. Cosine of angle x equals the adjacent over the hypotenuse, and then tangent of the angle x equals the opposite over the adjacent. Right? So SOHCAHTOA, if you know how to read that there, you can go and get all those letters there. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, right there. So we'll use that to help ourselves set up some equations here to go and solve these here. So let's try it out here on number 7. So what I do first on these is I label the angle, put a little hoop there, and then I go label the opposite, which is always across, the hypotenuse, which is always the longest side across from the 90 degree, and then this last angle here, we'll call that the adjacent angle, or the adjacent side of that 36 degree angle right there. Okay, big thing that people mess up, sometimes they swap the the A and H. The H is always the longest side though, so the H is always across from the right angle. Okay, then from there I decide what I'm going to solve for first. I'm going to solve for x, and I also use the side with the number right there. So we're solving for x, the adjacent side, we are given 9, the number right there. So then we are going to use the O and A function, which will be the tangent function. Okay, so there will be two parts to pretty much all of these here, so I'm going to kind of write small and over here to the left. So we'll say tangent of 36 degrees, and then equals 9, and then over x, the opposite over adjacent. Okay, now some people kind of learn the shortcuts. If x is in the denominator, it's a division problem. But one way you can solve these every time, if you don't know the little shortcuts, is write this as a fraction and then cross multiply these guys. X times tangent of 36 is just x times tangent of 36. And then 1 times 9 obviously is 9. And then you're trying to isolate x, so you divide both sides by tangent of 36 to cancel out tangent of 36 on both sides, or on the left side. So what you're going to type into the calculator is what we call calculator ready form. This is 9 divided by tangent of 36. And you don't need to use the function, the fraction function in your calculator. You just need to just type in 9 divided by tangent and then 36. And once again, make sure you are in degree mode, otherwise you're going to get some kind of crazy answers. Calculator's standard mode is in radian. So anyways, there's your decimal. We'll round appropriately. So let's see here. Round the side lengths to the nearest tenth. Okay, so we'll go one decimal place right there. So that'll be 12.4. The symbol for approximate or rounded answers right there. It's the little squiggly lines like that. So now we'll go and do the same exact thing here, except we'll go solve for y this time. So y, and we're going to reuse the 9 right there. I would not use the 12.4 for x, because if we mess up our work for x, then that's automatically going to mess up our work for y. So use the original things that they started you out with, and that'll help you minimize mistakes. So this one here, O and H is going to be the sine. That's the so part. So we'll go sine of 36, and then equals 9 over y, and then we can cross multiply again. All right. The shortcut is if the variable's in the denominator, eventually it's going to be a division problem that looks like this. So some of y'all might use that and say, okay, well then that means x is 9 divided by sine of 36. So you can do that little shortcut if you want, or you can just cross multiply again. Y sine 36 degrees equals 9, and then divide both sides by sine 36. And then And that's obviously what I wrote down there. And then let's see what that comes out to. 9 divided by sine 36. And barring that we type it in correctly, we should get the answer 15.3. Always like to take a step back and relook at the numbers that I guess solved for in this case, and I want to make sure the hypotenuse, which in this case is y, you want to make sure that's the biggest of the three sides. And you got 9, 12.4, and 15.3, so that does make sense. You do want that the largest side. Use the idea that small angles are across from small sides. So 36 degrees, that's a smaller angle. So your smallest side's going to be across from that. You know, if you wanted to go find this other angle right here, I guess you could say that's, what is that, 54 degrees right there. And I'm just adding that up, subtracting from 180. So across from 54 degrees, that should be the medium side. That was 12.4. So everything kind of checks out here on these triangles. I'm not going to do that on every single one or not walk you through it on every single one, but that can be helpful there on those. All right, I'll speed it up here a little bit on these examples here. Number 8, you got your 63 degrees. Your opposite side is going to be over here across from the angle. The hypotenuse is down here on the bottom this side, and then the adjacent is kind of that diagonal side. So remember, hypotenuse is always across from the right angle. All right, so we're going to use our h, and I'm going to solve for x here first. So that's O and h is going to be sine again. The sine is 63 degrees, and then equals x over 17. Now, if you want to use that same idea of cross multiplication, again, like we did on the previous example, we can say 1 times x is x, and then 17 times sine of 63 is 17 times sine of 63. You just type it into the calculator, and you can get your value there for that. Let's see what that's going to come out to. X, what am I doing? 17. You don't even need to hit times. You can just hit sine right afterwards. 63, as long as we type it in correctly here, 15.1. That looks like that's pretty good there on that. It's definitely smaller than the hypotenuse that we started out with, so that's good. All right, let's now go and get y. Y, I'm going to reuse the 17 again, the h, and then with the y, I'm going to use the cosine function on that one. That'll be cosine of 63 degrees. And then equals the adjacent over the hypotenuse, or y over 17. Okay, if you want to kind of use a shortcut, if the variable's in the numerator, it's always going to turn into multiplication. It's going to be 17 times cosine of 63 degrees. And then we'll just type that in. X is approximately 7.7. And that does make sense there. 7.7 would be across the smaller of the two acute angles. And then the 15.1, that's kind of like your medium side right there. That's across from your larger angle right there. So that'll be it on that one. Let's keep it going. Number 9. Number 9, you got, let's see here. There's your angle. There's your opposite. Here's your adjacent. Here's your hypotenuse. So I'm giving you the opposite side this time. Let's go ahead and find x first. O and A, that's going to be your tangent function. So we'll say tangent of 43 degrees, and then equals, what is that going to be? That's going to be 90 over x right there. Okay, and when you cross multiply and divide, you're eventually going to get x is equal to 90 divided by tangent of 43. So, and that's after cross multiplying and dividing, or using your little shortcut on that. If the variable is in the denominator, then it's division. That comes out to roughly 96. I guess I need to put approximate symbols. 96.5. Here, I'm going to actually kind of change my format here. Draw a horizontal line. Kind of split it up this way. Okay, now for x, for y, we'll use the h and then the o, and that's going to be your sine function. So that'll be sine of 43 degrees, and then equals 90, and then over y. Y is in the denominator. So when you cross multiply and divide, this is going to be y is equal to 90 divided by sine of 43 degrees right there. And then you can type that into the calculator, 90 divided by sine of 43. That's going to get you 113. I'm sorry, 131, not reading that right. Interesting little fact here. So when you're rounding this one, since the 6 will make the 9 round up, this is the best rounded. The best practice here for this is right, and that is 132.0, because that 9 is going to bounce up a little bit there. So 132.0. The other one was 96.5. Whatever units that they give you. Typically on the problems where they put units, I put units, or you could put like a little u for units. Just make sure that your hypotenuse is truly the longest side. Y is the hypotenuse. It's 132, so that does check out there. All right, and then finally we have number 10 here on this row. 10, slightly different here. Now you're going to find angles, and when you find your angles, you're going to have to hit second and then whatever trig function you're using, and that usually finds your angles. Okay, basically it's undoing the tangent button, or the tangent button, the cosine button, whatever you're dealing with. Now what's a little bit interesting here when we start with angle X is you have all three sides, so you actually just get to pick two and work with them. So just for kicks, I'm going to use the O and the A, or the 4 and the 3 right there. The trig function that uses O and A is tangent. But this time we write tangent x. We don't know the angle. That's what we're trying to find. And then that'll equal 4 over 3, or the opposite over the adjacent. Now as far as how do you undo or solve for x here, that's where you use the second trig functions. And what do I mean by second trig? You literally just type the second button and then whatever trig function you're using. And the way it'll look in the calculator is like this here. You do tangent inverse, undo tangent for the fraction or the ratio 4 over 3. And you can just type in 4 over 3 just like that, 4 divided by 3. You don't have to do the fraction button. And that's going to get us about 53.1 degrees. Let's see. They want angles to the nearest degree, so we'll go ahead and just round that to a clean 53 degrees. But that was rounded, so it is approximate there. Okay, now, two ways you can go get y from here. Okay, if you want to go back and get y, you could, if you're confident that you got 53 degrees correct, you could go and just say, well, hey, the two acute angles of a right triangle need to add up to 90. So you could just go 90 minus a 53, and that'd get you like 37 degrees. Now, if you're not confident in your answer, or if you want to double check and make sure everything adds up at the end, you could just do another trig function. The issue is, if you're going to find angle y, right here, your opposite side is going to change. So you would need to relabel everything here. The hypotenuse will still be the hypotenuse, but now the opposite side is 3 and the adjacent side is 4. So if you want to use tangent, again, that's totally fine, but now it's going to look different. It's going to be tangent of y degrees and then equals 3 over 4. And then when you type in the second tangent button, you'll put the 3 over 4, and then we can see what we get here. Oh, and make sure you type it in correct. Sometimes my finger's a little too big. And then hopefully that's the 37. Yep, that'll be roughly 37 degrees right there. And remember, these two answers, the two angles, need to add up to 90 degrees, or you could even add the 90 to that and say all the angles add up to 180. So that is that little section right there.